So for this video, we're looking at the definite integral as the area of a region. So what we have here is if you have some function f, and we're going to say f is continuous on a to b, some closed interval a to b. I'm also going to say f is non-negative, which is different from saying that it's positive, because if I said it was positive, it couldn't equal 0, but we're going to say f could actually equal 0. So it's continuous and non-negative on AB. Then what we would say is the area bound by, we're going to call it the area bound by f, the x-axis, the lines x equals a and x equals b can be given by this expression here. So we're going to say that it's the integral of our f of x dx, but it's not the indefinite integral. The indefinite integral would give us the antiderivative plus our constant of integration. It's going to be our definite integral, so it has bounds. It has a lower limit of integration, we'll call it a, and our upper limit of integration, b. It's continuous from a to b. This is the smaller number, this is the higher number. So from a to b, it is our area. Now, that's not to say that the definite integral always gives us an area, but it does in this case. So f has to be continuous on the closed interval from a to b. F has to be non-negative on the same interval. If that's true, then the area bound by our graph, f, the x-axis, and the lines x equals a and x equals b is this definite integral. So this could actually be a number. And if you look at the picture, you're going to have some function f, and I'm going to make it non-negative, and it could come down and actually touch the x-axis, but it's definitely continuous from x equals a to x equals b. So it's continuous and non-negative. Then the area bound by our function f, here, the x-axis, the lines x equals a and x equals b, this area is this integral expression. So we have some examples of different definite integrals. So this is a definite integral. It's the integral of 4 dx from 1 to 3. So for this, our function f of x equals 4. Or you could think of it as y equals 4. If I actually drew a picture of that, I have my x-axis, and I'm going to draw a horizontal line that is up 4. So here's my f of x, y equals 4, or f of x equals 4. This represents the area bound by this function, the x-axis, and the lines x equals 1 and x equals 3. So it's this area right here, which is a rectangle. It has a base of 2 and a height of 4. The area of the rectangle is base times height, so it'll equal 2 times 4, or 8. So this integral expression equals 8. If you look at this one, it gets slightly more complicated. You have f of x equals x plus 2, and I'm only interested starting with an x value of 0, so if I actually take this 0 and plug it in, I get 0 plus 2 is 2. And I'm going until I get an x value of 2, and this is linear, so I'm going to have a straight line. When x equals 2, f of x is 2 plus 2, so it's 4. And so this integral expression, this definite integral, is the area bound by f of x equals x plus 2, the x-axis, the lines x equals 0, and x equals 2. So it's this area right here. And people find that area in all different kinds of ways. You can actually just do it as a trapezoid. You can see that this would be our first base, this would be our second base, and this distance right here would be our height. Some people break it up into a rectangle and then a triangle. It doesn't really matter how you find this area, you just have to find it. So if I look at it as a trapezoid, I know that to find the area of a trapezoid, you're going to average the bases and multiply by the height. If it was a rectangle, it would just be base times height, but there are two bases, so I'll average them. So b sub 1 equals 2, b sub 2 equals 4. So it'll be 2 plus 4 divided by 2 times my height, which is 2. So this equals 6. So this integral expression would be 6. If I did it as a triangle and a rectangle, I could look at the rectangle. It's a 2 by 2, which is actually a square down here, although my picture doesn't reflect that, but that's an area of 4 for this piece. And then the triangle is 1/2 times the base times the height. So the base is 2, the height is 2, which is 4. Half of that is 2, so this would have an area of 2, plus an area of 4 is 6. It is important to note that this dx here tells you that these are x values. So if it changed, these values would change. So if this was a dy problem, then this would have to be a function of y, and these would have to be y values, and that's totally fine, but in this case, they're x's. If I look at this one, a lot of people don't recognize what shape this is, and it's actually something that you can determine geometrically. Just like this is the area of a rectangle, this is the area of a trapezoid, or turns out a square and a triangle. This one is actually a semicircle, and if I look at it, I'm going to write it as y equals the square root of 4 minus x squared and work backwards for a minute here. I'm going to square both sides. Y squared equals 4 minus x squared, add the x squared back, x squared plus y squared equals 4. And this is the equation of a circle. So we have x squared plus y squared equals r squared, the equation of the circle or Pythagorean theorem, and our r equals 2. It's a radius of 2. Now if I actually started with this and started solving this way and I took the square root, I would have plus or minus right here because I took the square root. The positive would be the top half of my semicircle, the negative would be the bottom half of the semicircle. And this, because it's x minus 0 and y minus 0, it's actually centered at 0, 0. So if I drew a picture of this, the center of my circle is 0, 0. I only have the positive square root, so it's the top part. It's a radius of 2, so I'm going to go 2 in each direction. And I'm going to draw it like this. So this represents the area bound by this function here, the x-axis, and the lines x equals -2 to x equals 2. So it's the area of the semicircle here. To find that, I know the area of a semicircle is 1/2 pi r squared. My radius is 2, so this will equal 1/2 pi times 2 squared. One of my 2's cancels out, and this equals 2 pi. So this integral expression is 2 pi. For this last problem, if I graph it, I'm starting at an x value of -2, and I'm going to an x value of 1. And again, this is a linear function that we're going to be graphing. Y equals 2x, or f of x equals 2x. When x equals -2, 2 times -2 is -4. You can imagine that's a straight line. So I have a point down here. If x equals 1, 2 times 1 is 2. So it's too high. And I have a straight line. This represents the area bound by this function, the x-axis, and the lines x equals -2 to x equals 1. But the problem is that my function is not non-negative. So the question happens, what do you do then? Well, I'm going to still look at areas to the x-axis. So I have this area down here which is a triangle, and this area up here, which is a triangle. This area it's a triangle, so it's 1/2 base times height, so it's 1/2. My base is 2, and my height is 4. So this is an area of 4. This section here is 1/2 base times height, so it's 1/2 times 1 times 2. So it's 1/2 times 1 times 2 equals 1. Now, because this is above, this is a positive 1, and this is below, this is actually a negative 4. So it no longer represents the area. It's more of a signed area. So this integral will be the combination of negative 4 plus 1 equals negative 3. So it does not represent the area because the area of my shaded region is actually 5. So it's very different. So this definite integral can still be found, but it's no longer the area of the region.